Hey YouTube, this is Berlagacademic, and today I'm going to talk about vectors and their application in search engines. Let's start out by assuming that we're searching in a language that only has two words, Donald and Trump. We're going to be searching for the word Donald. Let's assume we have 7 documents, all of which have different quantities of the words Donald and Trump. All of these documents are then assigned a vector, with the x component representing the number of times the document says Donald, and the y component representing the number of times the document says Trump. The search query, which is just Donald, is given a vector of 1, 0. Each document's vector is compared to the query vector, and then is given the cosine of the angle that the vectors make when compared to each other. The document with the largest cosine gets listed first in the search results. Document 1 is 5,2. Document 2 is 2,4. Document 3 is 1,1. Document 4 is 3,0. Document 5 is 0,5. And document 6 is 2,3. We now graph the query vector of 1, 0, or just Donald. We look at the angles the search vectors make with the query vector and list the cosines from largest to smallest. This is the same order of relevance from most relevant to least relevant of all the search results. This makes sense because document 4, which is just Donald, 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 is considered the most relevant search result, while the least relevant search result, document 5, has 0 of the word Donald. The two-word language seems very simple, but keep in mind we're only working here with 2 possible words. Let's add another one to the language, president. In this case, we would add another dimension. The search query, still being Donald, has a vector of 1, 0, 0. Now some of the documents include numbers of the word president. We form every vector from its corresponding document based on the x and y components as previously mentioned, but with the z component being the number of times the document says president. And the same process applies as we talked about before. We find the cosine the angles make with the query vector, and list the documents according to their cosines.
How's that pizza, Alex?
What?
How's that pizza?
It's not fresh cut. I need a fresh cut. Now what would happen if instead of searching for just one keyword, like Donald, I search for Donald Trump or Donald Trump President? Well, that just means you'd be changing the query vector. Donald Trump would make a query vector of 1, 1, 0, and searching for Donald Trump President would make the query vector 1, 1, 1. Now, in order to find the vector that is closest to the query vector, we would still have to find the cosine of the angle between the 2 vectors, but now in 3 dimensions. There is a formula for finding a cosine between 2 vectors. This formula is used to pinpoint the most relevant search results, the one with the largest cosine. But in the case where you have a large amount of documents, you have too many to sort. In order to cut time to sort the documents, we introduce a cutoff value. The computer selects a cutoff cosine value and eliminates every document with a cosine under that value. A direct effect of this cosine value is different numbers of search results. For example, a search for Donald Trump on Google will return 348 million results, while a search for David Degler will return 29,000 search results. Now let's extend this to the realistic model of the 1 million words in the English language. Just like 3 words require 3 dimensions, n words require n dimensions. Even though this seems impossible to visualize in the human mind, the computer can calculate this easily using the same formula as described earlier. The point is, it doesn't matter how many keywords or search results you have, the relation to each other can always be described by one single number, the cosine of the angle the vectors make with each other. Now this number can also be edited by a couple of things. synonyms of words in the query, how popular the result is, etc. But that's all done later in the programming, and it's less of a mathematical based thing. It's amazing how searching can all be done by comparing vectors and using words as numbers. It's almost that simple. This has been Berlagacademic. Thanks for watching.